Welcome to lesson 2 of looking at Internet and Web fundamentals. In this lesson, we're going to look at OSI reference model, what it is, why it was created, and how information gets transmitted on its various layers. This is the second video in my series where I'm teaching about the Internet and Web fundamentals. I've also shared the link to the comprehensive article about this lesson in this video description. During the last video, I talked about what is network, key components of the network, objective of the network topologies, client-server architectures with an example, and finally, how does the network work? I've shared the link in this video description below. My name is Anwar Mulombi from Mulan Technologies. If you have not subscribed to my channel, kindly do so. Hit that notification bell icon to receive instant updates whenever I upload a video in the coming days. Leave your comment below in the comment sections and share this video to help your friends know about it. Let us start. What is OSI model? The Open System Interconnection, abbreviated as OSI, reference model is a conceptual model that helps you understand how data in a networking environment actually works from one computer to another, regardless of where the computer is or what the software it runs. This model is composed of 7 layers, with each corresponding devices, protocols, standards, and application in the real world. Computer network specialists use the OSI model to aid them when designing, maintaining, and troubleshooting computer network. This lesson defines each of the OSI model layers, how they work, and associated protocols and application. And before we continue, let us look at why was the OSI model created. The OSI model was created and ratified by International Organization for Standardization, ISO. What is ISO? It's an non-governmental organization based in Geneva which develops and publishes international standards. It is represented in the US by the American National Standard Institute, ANSI. This OSI model was created to do the following. Number 1, explain network communication between hosts on a network. Number 2, present a categorization system for communication protocol suites. Lastly, show how different protocol suites can communicate with each other. That said, I want us to look at the 7 layers of the OSI model. The OSI model was created as a set of 7 layers, each of which houses different protocols within one of the 7 protocol suites, the most common, which is TCP/IP. The OSI models shows how a protocol stack works on different levels of transmission. That is, how it stacks up together against the model. As mentioned previously, during my topic on computer network, a LAN requires computer with network adapters. This must be connected together in some of the way to facilitate the transfer of data between them. The first layer of the OSI model is what referred to as the physical layer. This is the physical and electrical medium for data transfer. It includes but not limited to cables, jacks, patch panels, and hubs. Concepts related to the physical layer include topologies, analog versus digital encoding, bit synchronization, baseband versus breadband, multiplexing, and serial data transfer. If you touch a network element. It's part of the physical layer, which makes this layer one of the easiest to understand. Then the unit of measurement used in this layer is what we refer to as bits. The second layer of the OSI model is what we refer to as the data link layer. This layer establishes, maintains, and decides how transfer is accomplished over the physical layer. Devices that exist on the data link layer are network interface card, that's NIC, and bridges. This layer also ensures error-free transmission over the physical layer under LAN transmission. It does so through physical addresses, that's the hexadecimal address that is bound into the CD-ROM of the network interface card that we normally refer to as MAC address. The unit of measurement used on this layer is frames. Layer number 3 is what we refer to as the network layer. Network layer is dedicated to routing and switching information to different networks, LANs or internetwork. Guys, we will discuss more about routing and switching in the coming lessons. Devices that exist on the network layers are routers and IP switches. Here, we are getting into the logical addressing of hosts. Instead of physical addresses, the addressing system of the computer is stored in the operating system, for example, the IP addresses. At this point, you can see that a typical computer will really have two addresses, a physical address such as MAC address and a logical or software-based address such as an IP address. The unit of measurement used in this layer is what we refer to as the packets. And guys, just to let you know, a layer 3 switch differs from a layer 2 switch in that it determines paths for data using logical addressing, that's IP address, instead of the physical addressing, what we refer to as the MAC addresses. Remember, layer 2 of the OSI model is what we refer to as the data link layer. And we said that data link layer ensures error-free transmission over the physical layer under LAN transmission, and it does so through physical addressing mechanism that we always refer to as the MAC address. Layer number 4 is what refers to as the transport layer. This layer ensures error-free transmission between hosts through logical addressing. Therefore, it manages the transmission of messages through layer 1 to 3. The protocols that are categorized by this layer break up messages, send them through the subnets, and ensure correct reassembly at the receiving end, making sure that there are no duplicates or lost messages. This layer contains both connection-oriented and connectionless system. Inbound and outbound ports are controlled by this layer. So, guys, when you think of ports, think of the transport layer. The two TCP IP protocols that are utilized in this layer include the Transmission Control Protocol, which is connection-oriented protocol, and the User Datagram Protocol, UDP, which is connectionless. An example of an application that uses TCP is a web browser, and an example of an application that uses UDP is what referred to as a streaming media like YouTube. So just to break it down, when you download a web page, you don't want to lose any packet of information because graphics will appear broken. Certain text wouldn't read correctly and so on. By using TCP, which is connection oriented, we ensure that data gets to its final destination. If a packet is lost along the way, it will be resent until the destination computer acknowledges delivery or ends the session. But with streaming media, we are either watching or listening in real time. So if a packet is lost, we really don't care because that time frame for the video or music has already passed. The unit of measurement here is what we refer to as segments or sometimes messages. This layer governs the establishment, termination, and synchronization of sessions within the operating system over the network and between hosts. For example, when you log on and log off. This is the layer that controls the name and addresses of database for operating system. Network basic input output, that's NetBIOS, also work on this layer. Layer number 6 of the OSI model is what referred to as the presentation layer. This layer translates the data format from sender to the receiver in various operating systems that may be used. Concepts that include code conversion, data compression, and file encryption are found here. Directors also work on this layer, such as mapped network devices that enable a computer to access file shares on a remote computer. Then, the last layer of the OSI model is what we refer to as the application layer. This layer is where message creation and therefore packet creation begins. Database access is on this layer. End-user protocols such as file transfer protocol, symbol mail transfer protocol, telnet, RAS work at this layer. For example, suppose you are using an Outlook Express. You type a message and click send. This initiates symbol mail transfer protocol and other protocols which send mail messages down through the layers, breaking it into packets and the network layer, and so on. This layer is not the application itself, but the protocol that are initiated by this layer. Although in the earlier lesson, we defined each of the OSI models starting at the bottom, the physical layer, and moving upward there. Quite often, you will see the layers listed from top to down, with the application at the top and the physical layer at the bottom, as shown on this diagram, where we are having a transmitting computer and a receiving computer, and these layers are stuck on each other from top to bottom. That's from application to the physical, not like the other way when we start with the physical to the application. In general, just to break down this document, let us transaction start at the sending computer, travel down to the OSI layers, starting the application layer at the top and ending with the physical layer at the bottom, and are transmitted across the physical medium, be it wired or wireless, and travel back up levels of the OSI model at the receiving computer. For example, if you wanted to connect to our website, you will type the name of the site in your web browser address field. Then you press the enter. The HTTP protocol will take effect at the application layer. The packets of data will be compressed and possibly encrypted, that's HTTPS, by way of SSL or TLS at the presentation layer. The web server acknowledges the session with the client web browser at the session layer. The information will then be transmitted at TCP information on the transport layer, where the ports are also selected. The TCP information will be broken up into EC packets, into EC sent packets on the network layer, and an IP address information will be added. The packet will then be sent to the data link layer, where the network adapter will encapsulate them into frames of data. Then at the physical layer, the network adapter will break the frames up into the serial bit stream to be sent over the cable media. So just to aid you, the figure below, you can just review the OSI layers and show the corresponding devices, protocols, and network standard that apply in each other. Just to give an example, at line number 7, the application layer, the protocols that you have there, file transfer protocol, they have the HTTP, we have the POP3, we have the SMTP, and the device that is found there. An example is the gateway. Then we go to the presentation layer, concept of compression and encryption at the session layer, creation of session, that's the log on off and logging on and logging off. We have the transport layer, we have the TCP and UDP protocols, we have the network layer, things such as IP, ISMP, address resolution protocol, RIP, then the device, this layer 3, that's the routers. Then we have the data link layer and the physical layer. So you can take your time, study this table, and it will help you further. Then as we come to the end of this lesson, it's also good we also define the TCP IP model. We have just looked at the OSI model. We have another model referred to as the TCP IP model. The transmission control protocol, the internet protocol, are a set of standard rules that allows different types of computers to communicate with each other. The IP protocols ensure that each computer that is connected to the internet is having specific serial number called the IP address, the unique number. This model is similar to the OSI model. It's often used by software manufacturers who are not as concerned with how information is sent over the physical media or how the data link is actually made. Although the OSI model's reference model, the TCP/IP model, also known as the Internet model, is more descriptive, defining principles such as end-to-end and robustness, which describes strong endpoint connection and conservative transmission medium. This model is composed of 4 layers. The application layer, which makes sure that the data from the sending end is received in a format that is acceptable and supported at the receiving end. The second layer is the transport layer that is responsible for the smooth transmission of data from one end to another, and is also responsible for reliable connectivity, error recovery, and flow of control of data. Then you have the internet layer. Internet layer moves packets from one source to destination by connecting independent network, and the last layer is what referred to as the network access layer that sees how our computers connect to a network. We have seen that the OSI physical layer is skipped together, and the application layer comprises of the OSI application, presentation, and the session layer. Programmers utilizes the TCP/IP model more often than the OSI model, whereas network administrators usually benefit to a higher degree from the OSI model. Programmers are generally interested in the interfaces made to the application transport layers. Anything below the transport layer is taken care of by the TCP/IP stack within the operating system, which is set in stone. Programs can be made to utilize the TCP stack, but not to modify it. Thank you so much, guys, for watching. In the next video, I'll be talking about understanding Internet Protocol, IP addressing, how to categorize IP version 4, what is a default gateway, DNS server, and the concept of network address translation. See you there.